Hi everyone, in this video we are going to explore one of the most important real-life applications of calculus. It's called solving optimization problems. So what is an optimization problem? An optimization problem asks you to maximize or minimize a quantity, like area, value, cost, or distance under certain constraints. And to solve it, we use derivatives to find where the function reaches its highest or lowest point. And strategies for solving optimization problems need this step. So first, draw a picture and identify known and unknown quantities. Then write an equation that will be optimized. And write your equation in terms of a single variable. And determine the desired max or min value with calculus techniques. And last, determine the domain is the same as the endpoint of your equations to verify if the endpoint represents a max or min. Here is an example question. A particle is traveling along the x-axis and its position for the origin can be modeled by function x, where x is meters and t is minutes on the interval. So the question A, at what time t during the interval between the 0 and 4 is the particle furthest to the left? So first we need to know there are two informations in these questions. So first is the t values between the 0 and 4, what is also include 0 and 4. And the second is this question is asked for the furthest to the left. What is also means that we need to find the minimum value in this function. So solving this question, we need a derivative with these functions first. Then we need to find the maximum point. What we got is 3 and negative 2. And because the negative 2 is not between the 0 and 4, so only when t equal to 3 is in the intervals. And next we need to plug in the extreme point 3 and end point 0 and 4, plug in the original function. So we got the values what we have. And we compare these three values. We got when t equal to the 0, the function x is the lowest value. So the particle is the furthest to the left at when t equal to 0. And the second question is B. On the same interval, what is the particle's maximum speed? So it's asking about the speed, so we need to use a second derivative. So we go to the v prime. The functions also can help us to find the maximum point, what t equal to half. So it's asked for the speed, so we need to take absolute value for speed. So we absolute when we plug in the three different values, the end point 0 and 4, and when we got the extreme point is half. So we compare these three values again. We got the when t equal to the half, the function's v is the maximum value. So the maximum speed is 12.5 meters per minute at t equal to half. Here is another example. A rectangle is formed with the base on the x-axis and the 12 corners on the function y. Find the dimensions of the rectangle with the largest area. Here is a graph is on the right side. We can see we set the rectangle in the curve. The widest is 2x and the height is the function y. So we can use the equation of the area. Got the area is equal to 40x minus the 2x and square root 3. And then next we need the derivative, the area A. So we got 40 minus the 6x squared. Then next we need to find the maximum point. So we got the x equal to the 2 root 15 divided by 3. So next we need to find the dimensions. So we just plug in we got the x value, plug in the width and height. So we can got when width is equal to the 4 root 15 divided by 3 and height equal to 40 divided by 3. So when these two values appears, we got the largest area. Thank you for watching, and hope you can use derivative techniques to solving optimization question.